Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at the Pythagorean theorem. We're going to be using it to find the missing side of a right triangle. We're going to use it to determine if a triangle with specified sides form a right triangle, and also to solve an application problem. All right, let's take a look at question 1. It reads, identify the legs and the hypotenuse of the given right triangle and find the missing side x. Okay, so we have the right triangle right here. Let's go ahead and find what the legs and hypotenuse are. So let's start with the hypotenuse of this right triangle. Out of 5, 7, and x, which side represents the hypotenuse? So don't forget, this 90-degree angle is the biggest angle in the triangle, and the biggest angle is opposite the longest side. So if you go right across the 90-degree angle to the side opposite it, that is always your hypotenuse C. Okay, so there goes our hypotenuse right there. The other two sides are called the legs. A and B are interchangeable. It doesn't matter what you call what. So what we're going to do here is just call this A. All right, and then call this B right here, the side that we're missing. So this is the first leg, and this is the second leg. All right, so now we know the legs and the hypotenuse, so we can write them down. The legs are A equals 5 and B equals x. And then our hypotenuse is C equals 7. So now we're going to go ahead and find x, the missing side. Let's find x. So to get us started, we're going to write down the formula that relates the three sides of our triangle. Okay, so if you have a right triangle, the formula that relates to three sides is the Pythagorean theorem. Okay, so the Pythagorean theorem is a squared plus b squared equals c squared. All right, the sum of the squares of the two shorter sides is equal to the square of the longest side. All right, so let's substitute what we have into that equation. So a squared is 5 squared plus b squared, which is x squared, equals c squared, 7 squared. So now we have a quadratic equation. We're going to solve this. First of all, let's simplify it as much as we can, okay? Evaluate the squared constants. 5 squared is 25 plus x squared equals 49. All right, so let's get the variable by itself. So to accomplish that, let me copy that over here. 25 plus x squared equals 49. We subtract 25 from both sides of the equation to get the variable term isolated. Okay, and then when we do that, we're going to be left with x squared equals 24. All right, to get rid of the square, we'll use the inverse operation, which is the square root. So we're going to take the square root of both sides of the equation. Okay, and then x is going to be root 24. Let's go ahead and simplify that. See if it's possible to simplify. So let's break it down. 2 goes into 24 12 times. 2 goes into 12 6 times. And then 2 goes into 6 3 times. All right, so do you see any repetition of factors here? Absolutely. You see 2 2's repeat, so that's a perfect square. 2 times 2 is 4. All right, so the square root of 2 times 2, or 2 to the second power, or 4 is just 2 to the first power. All right, and then this 2 and this 3 have a power of 1, so their power is not high enough to be a perfect square. So they're going to stay behind in the radicand position. Okay, so if you simplify this term right here, if you simplify root 24, you're going to get x equals, so the 2 times 2, the root of that comes out as 2, and then 2 and 3 stay behind. Root 2 times 3 Okay, and then multiply those two terms in the radicand position together and you get root 6. Okay, so there goes your answer for this question. Question number 1, x is equal to 2 root 6. That's a measure of the second leg. All right, let's move on to question number 2. Question 2 reads, the three sides of a rectangle are 4, 5, and 6 units respectively. Is this triangle a right triangle? Justify your answer. All right, so let's give ourselves a visual of the situation. We're just going to draw a triangle. It's not necessarily right. And then populate the measures on the sides. Okay, so we have a right triangle here. I'm sorry, we have a triangle. We don't know if it's right. So this side length is 4, this is 5, and this is the longest side, 6. So the question is this side right here, this angle right here, is it 90 degrees since it's opposite the longest side? So we're going to label them A, B, C, call the longest side C, okay? Because if it is a right triangle, then that will be the C, okay? So call this A, B, and C. Now, how do we determine if this is a right triangle? We're going to do a test, okay? In order for this to be a triangle, the triangle must satisfy a special theorem. It must satisfy the Pythagorean theorem. Pythagorean theorem, which is a squared plus b squared equals c squared. So if we fill in this equation with a squared plus b squared equals c squared, if we have a true statement, then it passes the test and it's a right triangle. If it's not, it fails the test and is not a right triangle. Okay, so let's substitute a. We have 4. The question is 4 squared plus 5 squared? Notice we'll add in the square of the shorter sides. Is it equal to the square of the longest side? 6 square. Because that's how the Pythagorean theorem works. Okay, the sum of the square of the shorter sides is equal to the square of the longest side. All right, so 4 squared is 16. Is 16 plus 25, is it equal to 36? 16 plus 35 is 41. Is 41 equal to 36? No way. This is a false statement. So this triangle failed the test for the Pythagorean theorem. Okay, it's not a right triangle. This sum of the square of the shorter side is actually bigger than the longest side, so it's actually an obtuse triangle. It's not a right triangle. If it were less, then it'd be an acute triangle. Okay, so our conclusion is as follows. Conclusion: the triangle is not a right triangle. Why? It's not a right triangle since it does not satisfy the Pythagorean theorem. Okay? It doesn't satisfy the Pythagorean theorem. All right, don't forget, if you have any questions on any parts of this presentation, just specify it in the comment section and we'll explain it to you, okay? Number 3, Jack and Jill travel north and east respectively from the same starting point. If Jack travels 5 feet north and Jill travels 12 feet east, how far apart are they? Okay, so for this one, you need to remember what your 4 cardinal points are. All right, so your 4 cardinal points are, you have north on top, north, south, and east to the right, east and west. Okay, so that goes your 4 cardinal points right there. So in this particular case, they start from the same starting point, right? Jack travels north 5 5 feet. So let's say this is a starting point, 5 feet northwards, up, and then GL travels 12 feet to the east from the same starting point. All right, and then you kind of have a right triangle situation right here because the north and east directions are perpendicular to each other. All right, so this is a starting point. This is where 5 feet north. This is where Jack is. This is Jack's position. And then 12 feet east, this is Jill's position right here. So we're looking for this distance. This is the distance between them. This x value is what we're looking for. Distance between them. All right, so let's do it. So we need to write down the formula that will help us find x. We need a formula that relates the three sides of a right triangle, and that is the Pythagorean theorem, right? A squared plus b squared equals c squared. So let's label the sides. This is A, this is B, and this is C. Bam, bam, bam. Plug it in. A squared is 5 squared plus 12 squared equals x squared. X is what we're looking for. 5 squared is 25 plus 12 squared is 144 equals x squared. 25 plus 144 is 169 equals x squared. To get x by itself, we're going to do the inverse of this power of 2 operation, which is the square root. So you square root both sides of your equation, and you get 13. Okay, so the square root of 169 is 13. All right, so this side is 13. So something to keep in mind is the fact that if the three sides of if three numbers satisfy, three integers, or let's say whole numbers, if three whole numbers satisfy the Pythagorean theorem, there's a special terminology for them. They're called a Pythagorean triple. Okay, so 5, 12, and 13 are three integers or whole numbers that satisfy the Pythagorean theorem. So they are a Pythagorean triple. Okay, there are many other Pythagorean triples, so just keep that in mind. All right, so let's write down what this answer means. This answer basically means that the distance between Jack and Jill is what? Is 13 feet. 13 feet separation. Okay? So that's that. Thanks so much for taking the time to watch this presentation. Don't forget to help support our channel with your comments, shares, and likes. Tons of support resources can be found at mathgotserved.com. Do check it out. Also, the links in the description below. Thanks again for watching. We'll see you in the next video. Goodbye.